Okay, here's a little video to help prep you for the celebration on Friday. This is on 8.1 and 8.2. Okay, the first thing we want to do on this simple rational function is we want to tell the domain. So the domain is everything that we can plug in that doesn't cause 0 in the denominator. So we're going to say it's all the x's such that x can't be -1, because you can tell if you plug in a -1 in the denominator, that's going to be division by 0, which is undefined. Now also the vertical asymptote is x equals -1, because again that's the number that you're never allowed to plug in. So that means you're going to have a vertical asymptote right here at -1. Okay, the horizontal asymptote is going to be normally before it had any adjustments, it's y equals 0. Like if the function was just this, it would be y equals 0 because the denominator has a bigger degree than the numerator. But it's been shifted down 5 units, so then it's going to be 1, 2, 3, 4, 5. So then the horizontal asymptote is going to be at -5. So this will be y equals -5. And then you can go ahead and graph it on the calculator to figure out where it is, or you can remember that it's in these locations here, the lower left and the upper right. And you try to draw your graph in such a way that it actually approaches the asymptotes without touching them. Okay, the next one, pretty similar. You can tell that this one has been shifted to the right 2 units because it's x minus. So that one, remember, is sort of the opposite. So it's been shifted 2 units to the right. So we'll say 2 units right. And then because of the plus 10, it's 10 units up. And then it's also been reflected. So we're going to say reflection over the x-axis. Now the domain is anything, that doesn't cause 0 in the denominator. So we're going to look for those numbers. We're going to say the domain is all the x values such that x does not equal, and we're not allowed to have it be 2, so we're going to say x can't be 2, because that's going to cause division by 0. Alright, so this one's already graphed for us, so then we just want to list everything according to the graph. So we can tell the vertical asymptote is right here at x equals 3, so we're going to say x equals 3. We can see the horizontal asymptote. It looks like it's right here, and it's right, on the x-axis there, so that's y equals 0. It looks like there's a hole right here at an x value of -2. No, sorry, at x equals 2 right there. So x equals 2. And then the end behavior, we can see that as x approaches infinity, the y value is approaching that horizontal asymptote, which is 0. As x approaches -infinity, we can see the graph is getting, closer to 0. So again, it's approaching that horizontal asymptote. And then what we want for the middle part is as x approaches whatever the vertical asymptote is. So this is 3. So we're going to say as x approaches 3 from the right, and as x approaches 3 from the left, that's supposed to be a little negative sign. It's supposed to be up high, so it would be 3 from the right, and then this one here would be 3 from the left. It should be up, kind of like where the spot where the exponent is, that high. So as x approaches 3 from the right, what's happening is the y values are approaching positive infinity because they're going up, increasingly, getting greater. And then as x approaches 3 from the left, it's going to negative infinity. And again, you can see that hole right there at x equals 2. Okay, so same directions on this one. We have a vertical asymptote. It looks like it's right here, and that's at x equals 1. The horizontal, this is an awesome dog we're babysitting. The horizontal asymptote is y equals -4. And then the hole is going to be right at that open circle there, so we can see that it's x equals 3. The end behavior, as x approaches infinity, you can tell that the y value is approaching whatever the horizontal asymptote is. So y is approaching -4. And then as x approaches negative infinity, we can see that the y values are approaching the horizontal asymptote again, which is -4. Then as x approaches, the other part there is the vertical asymptote. So the vertical asymptote is x equals 1. So we're going to say as x approaches 1 from the right, a little plus sign there, as x approaches 1 from the left. So as x approaches 1 from the right, we can see that it's getting bigger, so it's going to be y approaches infinity. As x approaches 1 from the left, we can see that the y values are getting smaller, so we're going to say negative infinity. And then, like I said, we already have a hole there. We said the hole was at x equals 3. It's listed there as 3, -2, so there's your hole. All right, so this one, we're going to go ahead and list the things we can. So the domain is all the values except the ones that cause division by 0. So we're going to say all the x values such that x can't be, and we can tell that -2 is what's going to make that denominator equal 0 there, and then also a 0. So x can't be 0 or x can't be -2. What you're doing is you're just setting each of those little factors equal to 0 to figure out the numbers that cause the denominator to equal 0. Now the vertical asymptote is going to be, well, let's do the holes next. So any factor that cancels out, so you can see the x's cancel out. So that means there's a hole at x equals 0. And then whatever is left, we have x minus 3 left over, and then we have x plus 2 left over. And actually we have a 3 in front of that as well. So that means that we have a vertical asymptote at x equals -2, because we still have a factor on the bottom that's x plus 2. Okay, now sometimes you have to do a little bit of factoring first before you can tell what the domain is. So let's do a little factoring there. So this will be two numbers that multiply to be -21. So, and then they add up to be -4. So let's think about that. So probably like -7 and +3. So let's do x minus 7 and x plus 3. See if that works. Okay, that looks like that works. So now we're going to be able to tell the domain. We're going to say it's all the x values such that x can't be, and it looks like 7 is what's going to make that this factor equal 0, and then -3. Okay, the vertical asymptotes, it's actually going to have two of those because nothing really cancels out. So it's going to be x equals +7 and x equals -3. The horizontal asymptote is going to be, because the degree on the bottom is going to be x squared when you multiply those two together. Well, actually right here you can tell it's x squared. The degree on the bottom is bigger than the top, so that means it's always going to be y equals 0. The holes actually doesn't have any holes because no factors cancel out, so we're going to say none for that one. Okay, so this one has a little bit of factoring for us, so we get to practice. So we're going to do a double bubble on the top, and we're going to do a double bubble on the bottom. On the top, it's going to be two numbers that multiply to be -7, and they add up to be -6. So that's going to be, let's see, that's going to be -7 and +1. So that means we can put x minus 7 and we can put x plus 1 there. Then this other one, we have two numbers that multiply to be 14 and they add up to be negative 9. So they multiply to be that, add up to be that. So let's go with negative 7 and negative 2. So that means these would factor as x minus 7 and x minus 2. So then the x minus 7s are going to be able to cancel out, but let's do the domain first. So let's say all the values of x such that x can't be positive 7 and positive 2. Okay, and then the vertical asymptote, well, let's do the whole next. So then this factor cancels out because they both have an x minus 7. So that means there's a whole at x equals 7. And then whatever's left would be x plus 1, simplified function would be x plus 1 over x minus 2. And then you can tell the vertical asymptote is whatever factor is left. So we have x equals 2. The horizontal asymptote is whenever the degrees are the same, like this is x to the first and this is x to the first, it's the little coefficients that are in front. So this is 1 over 1. So that means the horizontal asymptote is y equals 1. Okay, now we're going to be able to work backwards a little bit. So we know that these are rational functions. So we're going to say f of x equals, and we're going to make ourselves a little bar here. So the vertical asymptote being x equals 7 means that we're going to have a factor on the bottom that's x minus 7. When there's a whole that is x equals negative 3, then that means that there's a factor that canceled out that was x plus 3. So we have to put x plus 3 on the top and the bottom, because again, if you slice that out, the whole would be right at x equals negative 3. Then the horizontal asymptote is supposed to be y equals 1/2. Now the only way that that could happen is if the degree was the same on the top and the bottom, and then there was a little 1 in front of here, and then there was a 2 on the bottom. So what we have to do first is kind of make sure that they even have the same degree, because on the bottom right now it's going to be x squared, and on the top it only is x plus 3. So let's go ahead and put an extra x in there on the top. Then at least it would be x squared as that first term. And then we also need to have a 2 on the bottom, so we just could put a 2 on the bottom like that. And that would do the trick, because when you multiply these together, that would be x squared. And then when you multiply these two together, that would be x squared, and then you'd have this 2 as a leading coefficient. So it'd be kind of like, it'd be x squared as the first term. I mean, you could go ahead and do the whole thing. It's not totally necessary. Then this bottom part, at least the leading term would be 2x squared on the bottom. And then you could tell that the fraction in front would be 1 over 2, which would get you that horizontal asymptote. So this is your function that would meet that criteria. All right, let's take a look at another one. So the vertical asymptote is x equals negative 9. So that means there's a factor on the bottom that is x plus 9. So check, that one's ready. No holes, so we don't have any factors in common on the top and the bottom. It says the horizontal asymptote is y equals 5. The only way that could happen is if you had the same degree on the top and the bottom. So that means if this one's an x, this one on the top would have to be an x. And the only way you can get a 5 to be the horizontal asymptote is if you had 5 over 1. This one's already a 1, so just 5x on the top would do it. So 5x over x, and then you can tell again that that horizontal asymptote would be y equals 5. So that would be good. 5x over x plus 9. You don't really need to have that 1 in front. Okay, I think just the one more here. So f of x equals, and then the denominator, we need to have a factor of x minus 8. And then we do have a whole in this case. The whole is x equals negative 4. So that means we must have canceled out a factor that was x plus 4. This one says it doesn't have any horizontal asymptote. So the only way that it cannot have a horizontal asymptote is if the degree on the top is actually bigger. So right now, this is x times x, which would give you x squared. And right now on the top, it's only an x. So the top would have to be x cubed. So it would have to be bigger. So that means we have to multiply the top by x squared. Because then that would be x squared times x, which would be x cubed. And then that would be bigger than the bottom. So that would be enough to fix it. All right. So I think that'll do it for us. Let me just make sure that was my last one. Yeah. Okay. So good luck.